All right, today we're cracking open the AI Toolbox. We're going to look under the hood at the powerful engines driving the technology that's, completely changing our world. So let's jump right in.
Have you ever wondered about that? How does Netflix just know what you want to watch next? Or how does your phone instantly find all the faces in a photo? It seriously feels like magic, but I promise you it's not. It's a combination of some brilliant engineering and a whole set of very clever machine learning models. And that right there is the key idea for this whole explainer. See, there isn't one single AI that does everything. It's more like a workshop full of different tools. The real secret to building amazing AI is knowing exactly which tool to pull out for which job. So, here's our game plan. We're going to take a tour of that toolbox. We'll start with the foundational tools, then look at the predictive powerhouses, check out the new creative frontier, and then move on to AI that actually acts. And finally, we'll talk about how you choose the perfect tool for what you want to build.
Okay, first up, the foundational tools. I want you to think of these as the absolute essentials, the hammers and screwdrivers of machine learning. They're reliable, they're versatile, and you're going to find them on pretty much every project.
At their core, these foundational models are all about prediction. They're basically built to answer two super simple questions. How much of something, or that classic, is this thing A or is it B? That's pretty much it. And this table breaks down that difference perfectly. On one side, you've got linear regression. Its job is to predict a number on a sliding scale, like what's a house going to be worth. On the other hand, you have logistic regression. It's a classifier. It just sorts things into two buckets. Is this email spam or is it not? See? Two simple tools for two very different, but really crucial jobs. Then there are decision trees. I love this one because it's so easy to picture. It's basically the AI version of playing the game 20 questions. It just asks a bunch of simple yes or no questions to get to an answer. And because of that, it's incredibly easy to see why the AI made the choice it did, which, as you can imagine, is super important for things like deciding on a loan approval. Okay, we've got our basics down. Now, let's open the next tray in the toolbox. We're upgrading from the hand tools to the power tools now. These are the models you bring out when you've got much more complex jobs to tackle.
So this brings us to what are called ensemble models. Now that sounds kind of fancy, but it's really just a way of saying teamwork. Instead of relying on one single model, these methods combine hundreds, maybe even thousands of simpler ones. It's literally the wisdom of the crowd, but for AI.
A perfect example of this is a random forest. Remember those simple little decision trees we just talked about? Well, a random forest just builds a whole bunch of them, a forest of them. Then each tree gets to vote on what it thinks the right answer is, and whichever answer gets the most votes wins. That one simple act of voting makes the final prediction way more accurate and reliable than any single tree could ever be on its own.
And then there's gradient boosting. This is the ultra-competitive, high-performance power tool. Here's how it works. It builds one model, looks at where it messed up, and then builds a new model specifically to fix those mistakes. It keeps doing this over and over, getting a little bit smarter each time. So when you absolutely positively need the highest accuracy you can get, this is the tool you reach for. Now we're getting to the real specialists, neural networks. And just like a power drill has different bits for different jobs, neural networks come in different flavors. You have convolutional neural networks, or CNNs, which are masters of spatial data. They see the world in pixels, which makes them perfect for stuff like face recognition. Then you have recurrent neural networks, or RNNs. They specialize in sequences, like words in a sentence, which is why they're so critical for something like language translation. Okay, so far, all our tools have been about predicting and classifying things that already exist. But the next train in our toolbox, this is where things get really wild. This is where we find the AI that doesn't just analyze the world, it actually adds to it. It creates. And the undisputed rock star of this whole section is the transformer model. You might not know it by name, but you absolutely know its work. Because this is the revolutionary architecture that powers tools like ChatGPT. So what makes transformers so special? Well, they're absolute wizards at understanding context and language. They don't just see individual words, they see the relationships between all the words across huge paragraphs of text. And that is what lets them generate sentences that are so incredibly coherent and contextually aware, making them the backbone for all these advanced chatbots and even tools that help write computer code. But that's text. What about creating images? For that, we turn to another mind-blowing tool, diffusion models. These are the models that are literally teaching machines how to dream, turning a simple line of text from us into these stunningly detailed images. The process itself is just fascinating. These models start with pure random noise. Think of old TV static. And then, step by step, they gradually refine that static until it perfectly matches a text description. It's this whole from noise to art process that powers those incredible text-to-image tools we see everywhere now, like DALL-E and Stable Diffusion. We've seen AI that can predict and AI that can create. So, for our final section, let's look at our last class of tools, the ones that build AI that can actually act, making its own decisions and interacting with the world.
And this is a really important distinction to get. The models we just saw, like transformers and diffusion, are generative AI. Think of them like a 3D printer for data. They create new stuff. But the models we're about to look at build agentic AI. They're the brains inside a system that takes action on its own, kind of like a self-learning robot.
The engine that drives this kind of AI is called reinforcement learning. And the idea behind it is wonderfully simple but so powerful. You create what's called an agent. You put it in an environment, and you just let it learn by pure trial and error. When it does something good, you give it a little reward. When it messes up, a little penalty. You do this millions of times, and eventually it learns the best possible strategy to get the most rewards. And this learning by doing approach is how AI can achieve superhuman performance in some incredibly complex situations. It's the technique that powered AlphaGo, the AI that mastered the game of Go. It's how we train robots to handle objects, and it's a critical piece of the puzzle for developing autonomous cars that have to react to a constantly changing world. So, we've toured the entire toolbox, from the basic screwdrivers all the way up to the robotic arms. And that brings us to what is maybe the most important lesson of all. There's no single best model. It's always about picking the right tool for the specific job you need to do. It really all comes down to this simple choice. The first question you always have to ask is, what's my goal? If you need to create something new, whether that's text or images or code, you're going to reach for a generative model. But if you need your AI to actually do something, to take action, you'll use an agentic model powered by reinforcement learning. Just understanding what's inside the AI toolbox is the first huge step toward using its power. These tools aren't just for predicting things anymore. They're for creating art, helping us with our work, and even navigating the real world. Which leaves us with one final and really exciting question to think about.